Everyone knows about German U-boats, the steel wolves, the silent hunters that terrorized Atlantic shipping lanes and changed the course of naval warfare forever. But here is something almost nobody talks about. Every single U-boat that ever slipped beneath the waves was carrying not just torpedoes and fuel and terrified young men. It was carrying books. Not novels, not personal diaries. Formal, structured, legally required official logs. Multiple ones. Separate books for navigation, for radio communications, for engineering, for supplies, for operations. Each one maintained independently. Each one filled out by a different officer. Each one telling a completely different version of the same patrol. And the reason why is one of the most fascinating stories in all of military history. It touches on bureaucracy, on survival psychology, on intelligence tradecraft, on the engineering demands of undersea warfare, and on a command culture so obsessed with documentation that it kept writing even when the ship was sinking. If that sounds like something worth understanding, hit subscribe before we go any deeper, because this is the kind of story that rewards attention, and we are just getting started. To understand why U-boats maintain separate logs, you first have to understand what a U-boat actually was. Not the cinematic version, not the dramatic tension of Das Boot. The real thing. A U-boat was not a sophisticated machine by modern standards. It was a cylindrical steel tube crammed with diesel engines, electric motors, torpedo tubes, fuel tanks, compressed air flasks, ballast tanks, hydroplanes, periscopes, a radio room, a navigation station, bureaucratic indulgence. They were the connective tissue of the boat. They were how a vessel operating in total alight positioning or radio beacons that could be trusted. It was operating with a magnetic compass, a chronometer, a sextant when it could surface, and a method called dead reckoning that is both elegant and terrifying in its demands for precision. Dead reckoning means you take your last known position, you apply your known speed, you apply your known heading, you account for estimated current drift, and you calculate where you must be now. Every hour you fail to surface for a star fix, the potential error compounds. A small mistake in recorded speed becomes a larger error in position over time. A slight compass deviation, uncorrected, can put you miles from where you think you are. The navigation log existed to eliminate accumulated error. Every single course change was recorded. Every speed change was recorded. Every watch transition was recorded, because the navigator needed to be able to reconstruct the entire movement history of the vessel at any moment. If the boat surfaced and finally got a proper star fix, the navigator could compare the calculated position against the actual position and calculate how much drift had occurred, what the magnetic deviation was proving to be in this particular part of the ocean, and correct forward. Without a meticulous, continuous written record, this correction process was impossible. But there is something even more profound about the navigation log. It was a legal document. In German naval law, the navigation log of a vessel was an official record with evidentiary standing. If there was ever a dispute about where the boat had been, whether it had entered a neutral nation's territorial waters, whether it had been in a declared exclusion zone, whether it had received warning before an attack, the navigation log was the primary reference. This meant the navigation log could not simply reflect whatever the captain wanted to say happened. It had to be a continuous, witnessed record maintained by the watch officer, separate from the captain's own records. The accountability structure was built into the format. There is a direct parallel here to maritime law that stretches back centuries. Every commercial vessel, every naval vessel of every navy, has always maintained some form of navigation log precisely because the sea is an environment where disputes are common, accidents happen without witnesses, and the difference between a war crime and a legitimate act of war can come down to exactly where a ship was at exactly what time. The Germans were not inventing something new. They were applying a tradition that was already ancient and adapting it to the specific demands of submarine warfare. Now let us look at the radio log, because this one reveals something genuinely strange about how U-boat warfare was actually conducted. The U-boat radio log was not simply a record of messages sent and received. It was, in many cases, one of the most sensitive documents on board. Every message that came through from BDU, Befehlshaber der Unterseeboote, the U-boat command headquarters run first by Karl Dönitz and then by his successors, was encoded using the Enigma machine and had to be decrypted on board and recorded. Every report sent back to headquarters had to be composed, encoded, transmitted, and logged. The radio log tracked not just the content of these communications, but the exact time of transmission, the frequency used, the signal strength noted, and the acknowledgement status. Why does this matter? Because one of the greatest vulnerabilities of U-boat warfare was radio communication itself. When a U-boat transmitted, it revealed its presence. Allied direction-finding technology, called Huff Duff by British operators, could triangulate a U-boat's position from its radio transmissions with alarming accuracy. British and American ships were equipped with these systems from the early years of the war, and they were extremely effective. A U-boat that transmitted even a short burst signal could be located within minutes, with destroyers or aircraft being vectored onto its position. Dönitz knew this. His operational doctrine evolved throughout the war to minimize radio transmissions. Boats were instructed to transmit briefly, use shortened signal codes, and keep communications to absolute minimums during active patrols. But here is the tension. Dönitz also ran a command style based on tight centralized control. He wanted to know where his boats were. He wanted to direct Wolfpack attacks from headquarters. He wanted to gather intelligence reports about convoy positions and merchant shipping. This required radio communication, and it killed boats. The radio log was the record of this tension. By examining a U-boat's radio log, you could reconstruct exactly when the boat had transmitted, how long it had been on the air, what it had reported, and potentially correlate that with the timing of Allied responses. After the war, when Allied intelligence records became available and the Enigma secret was finally revealed, historians used both sides of this equation together, the German radio logs and the British signals intelligence records, to reconstruct in precise detail how the Battle of the Atlantic had actually been fought and decided. The radio log was also a crew safety document in a way that is easy to overlook. It was directly tied to both tactical decisions and mechanical realities. The engineering log tracked all of it. The Germans were running dozens of boats, rotating them through French Atlantic bases at Brest, Lorient, Saint-Nazaire, La Rochelle, and Bordeaux, and the logistical challenge of keeping them all operational was staggering. The engineering logs were the database that made it manageable. Now let us look at the supply log. And this is where the human element becomes almost unbearable. A U-boat going on patrol in the North Atlantic in 1942 carried enough food for roughly 8 to 12 weeks at sea. This sounds reasonable until you consider that the crew was typically between 45 and 60 men, that refrigeration was extremely limited, that fresh food spoiled within the first week or two, and that the remaining weeks at sea were sustained by canned goods, dried foods, preserved meats, and whatever had not gone moldy in the damp air of the pressure hull. The supply log tracked all of it: food stores by category, fresh provisions remaining, canned goods by type, preserved provisions, fresh water remaining, which was separate from ballast water and was critically important because men who become dehydrated in a hot, cramped submarine become impaired, and impaired men make fatal mistakes. But the supply log also tracked something that is easy to overlook when thinking about submarine warfare: torpedoes. A Type 5 U-boat, the most common German submarine of the war, carried 14 torpedoes. Torpedoes were not reloaded at sea under normal circumstances. Once they were fired, they were gone. The supply log tracked how many had been fired, at what targets, with what results if observable, and how many remained. This was critical for two reasons. First, the captain needed to know his remaining offensive capability at any moment. A boat with 3 torpedoes remaining was in a fundamentally different tactical position than a boat with 12. Second, headquarters needed this information when directing Wolfpack attacks. If a boat was running low on torpedoes, it might need to be recalled while other boats with fuller loads were directed into the attack. The supply log also tracked the compressed air reserves used to fire those torpedoes, and this creates a connection between the supply log and the engineering log that illustrates why separate logs were necessary rather than one combined document. The torpedo air pressure was an engineering concern in its mechanical maintenance and readiness sense, but it was a supply concern in terms of how much had been expended and what remained available for further use. Different officers owned these different perspectives, and keeping them separate ensured that both perspectives were captured accurately rather than one officer's priorities dominating the record. Fuel is another critical element of the supply log. A U-boat carries a finite amount of diesel fuel. Fuel consumption is affected by speed, by sea state, by how much time the boat spent snorkeling versus fully surfaced, and by mechanical efficiency. The supply log's fuel record had to be reconciled against the engineering log's engine hours and consumption rates on a regular basis. If the two records disagreed, something was wrong. either a calculation error, an unrecorded expenditure, or a fuel leak that needed to be found and fixed. The cross-checking function of separate logs was built into the system by design. There is also a darker dimension to supply log keeping that is rarely discussed. In the latter years of the war, as Allied anti-submarine warfare became more effective and U-boat losses mounted catastrophically, boats sometimes ran patrols that extended well beyond their planned duration because they were evading pursuit, or because they had been damaged and could not safely make for port, or because they had received orders redirecting them to a new operational area without a resupply opportunity. In these situations, the supply log became an increasingly grim document. Food running low, water running low, air recycling compounds becoming depleted, battery reserves diminished from repeated deep dives. The supply log was where the arithmetic of survival was computed in black ink. Captured supply logs from the later war years sometimes read like the records of a slow emergency. Officers carefully noting reduced rations, calculating how many more days they could sustain operations, recording the condition of remaining provisions as quality declined under heat and humidity. These documents tell a story that the operational war diary, focused on tactical events, does not fully capture. They tell the story of what it actually cost to keep men alive and fighting in the deep ocean. Now we arrive at the operations log, which is perhaps the most studied of all U-boat documents, and the one that historians have spent the most time analyzing. The Kriegstagebuch, or KTB, the war diary, was the master operational record of every patrol. It was maintained by the captain himself, or under his direct supervision, and it recorded every significant event of the patrol in narrative form. The departure from port, with crew status and weapons load. The transit to the operational area, weather conditions encountered, any contacts made with enemy ships, aircraft, or other submarines. The details of any attacks, including the torpedo type used, the range, the bearing, the speed and course of the target, the time of fire, and the observed result. Any depth charging experienced, with the number of charges counted, the estimated depth of detonation, and the duration of the attack. Communications received from headquarters. Any mechanical problems that affected operations. The return transit. Arrival in port. The KTB was required to be submitted to BDU upon every patrol's completion. Dönitz personally read them, or at least he read summaries of them. In the early years of the war, when the U-boat fleet was smaller, he reviewed the actual texts of many patrol diaries himself. He used them as the primary source for his understanding of how the war was actually being fought. When he noticed a pattern, a particular enemy tactic that kept appearing, a specific area where boats were consistently finding targets, a type of target that was proving difficult to sink with available weapons, he could respond with updated operational guidance. This created a feedback loop between the individual boat's operational record and the strategic direction of the campaign. The KTB was not simply a historical record, it was an active management tool in real time. And because it was maintained separately from the navigation log, the radio log, the engineering log, and the supply log, the KTB could focus purely on operational events without being cluttered by the technical data that those other logs contained. The captain writing in the KTB did not need to record battery voltage levels because the engineer log handled that. He did not need to record signal frequencies because the radio log handled that. He could focus on what actually happened at sea, in tactical and strategic terms, and trust that the other logs were creating the complete picture. There is a crucial intelligence dimension to the KTB system that became enormously important as the war progressed. In May 1941, the British captured U-110, and with it, they obtained an Enigma machine, its associated codebooks, and a cache of operational documents including log materials. This was one of the most significant intelligence coups of the entire war, and it gave the British and later the Americans direct insight into how U-boat operations were being documented and communicated. The detailed structure of German U-boat logging practices, once understood, could be exploited. If you know what information a U-boat is required to log and transmit, and you have broken the code those transmissions use, you can reconstruct operational patterns with extraordinary precision. The British Signals Intelligence operation at Bletchley Park did exactly this. By combining their ability to decrypt Enigma-encoded radio traffic with their understanding of what German naval logging requirements produced in terms of standardized report formats, they could interpret incoming traffic quickly and accurately. A position report had a known format. A contact report had a known structure. A fuel status report transmitted on a specific schedule had a predictable content. The standardized logging requirements that produced these standardized transmission formats were precisely what made them readable and exploitable even under encryption. This is one of the great paradoxes of the U-boat war. The rigorous logging system that made German submarines so professionally administered and so effectively managed also made them more vulnerable to intelligence exploitation. The very thoroughness of the documentation created patterns. And patterns, in the intelligence world, are things that can be read by enemies with sufficient sophistication. The understanding why 5 separate logs were required rather than one master record requires understanding German naval culture, and that culture has roots that go back well before the Nazi period to the traditions of the Kaiserliche Marine, the Imperial Navy of the First World War and before. German naval tradition emphasized precise functional accountability. Every department of a ship had a defined sphere of responsibility. Every department head was personally accountable for their sphere. The navigation officer was responsible for navigation. The chief engineer was responsible for machinery. The radio officer was responsible for communications. The supply officer was responsible for provisions and munitions. The captain was responsible for operations. These accountabilities were not merely organizational. They were legal. They were professional. They determined who was praised or blamed when things went well or badly. The separate log system enforced these accountabilities in a tangible way. The navigation officer who falsified or neglected the navigation log was not just being careless about paperwork, he was failing in his professional duty in a way that was documented, reviewable, and attributable specifically to him. The same principle applied across every log. This created a professional culture in which detailed, accurate record-keeping was understood as an expression of professional identity rather than administrative burden. German naval officers did not merely accept the logging requirements. They understood why those requirements existed and took pride in fulfilling them rigorously. This cultural context also explains why the logs survived as frequently as they did. One of the remarkable facts about U-boat history is how many log documents were preserved. Boats were ordered to destroy their logs and their Enigma materials if capture was imminent, and many did. But a surprising number of patrol documents survived because captains and officers were reluctant to destroy them. The log was not just a bureaucratic artifact. It was the professional record of what the crew had done and endured. Destroying it felt, to many officers, like destroying the evidence of the patrol itself, like erasing what they had been through. There is something deeply human in this reluctance. The supply log that recorded carefully rationed food during a 12-week patrol was also the document that proved what those men had survived. The engineering log that recorded the depth charge damage they had taken and the repairs they had made at 60 meters was also the testimony of what the engineer and his team had accomplished under impossible conditions. These were not merely official records. They were witnesses. The engineering dimension of separate logging becomes even more important when you consider the evolution of U-boat technology during the war. The early Type 7 boats that began the war were effective but mechanically relatively simple by later standards. As the war progressed and Allied anti-submarine warfare became more lethal, the Germans raced to introduce new technologies. The snorkel, which allowed the diesels to run while submerged at periscope depth and greatly reduced the need to fully surface. Improved acoustic quieting measures to reduce the noise signature that Allied sonar could detect. New torpedo types, including the acoustic homing torpedo known as Zaunkönig or Gnat, designed to home in on the propeller noise of Allied escort ships. New radar warning receivers that could detect Allied centimetric radar, which the Germans were initially unable to detect at all, and which was responsible for numerous surprise attacks. Each new technology required new engineering log entries, new maintenance procedures, new performance parameters, new failure modes that the engineer needed to understand and document. The engineering log was not a static document describing a static machine. It was a living record of an evolving weapons system responding to an evolving threat environment. Keeping it separate from the other logs allowed the engineering documentation to grow and adapt in its own right, without competing for space or clarity with navigation data or operational event records. The snorkel is worth examining in detail because it illustrates how a single technical change could cascade through multiple log categories simultaneously. When a U-boat snorkeled, it raised a tube above the water surface that allowed the diesel engines to draw air from outside and exhaust their gases outside, while the boat itself remained at roughly 8 to 12 meters depth. This was tactically revolutionary because it dramatically reduced the boat's vulnerability to aircraft attack, which had become the primary killer of U-boats by 1943. But snorkeling was technically demanding and created new engineering challenges. The snorkel head valve had to open and close based on wave action, and if a wave covered the intake, the diesels would draw air from inside the pressure hull, creating a partial vacuum that was deeply unpleasant and potentially dangerous for the crew. The snorkel head itself was a radar reflector and had to be kept as small as possible while still functioning. The diesels running at depth produced noise that sonar could potentially detect. The engineering log now had to track snorkel hours separately from surface running hours. It had to record snorkel head valve maintenance. It had to document the vacuum incidents that occurred when the head valve closed unexpectedly. It had to note any hull penetration seal issues related to the snorkel mast housing. All of this was new data that needed its own record space and its own engineering context. Simultaneously, the navigation log had to record snorkel navigation differently from surface navigation because the navigator's ability to take visual fixes and visually assess position was reduced when snorkeling. The radio log had to note that certain transmissions could not be made while snorkeling because the antenna situation was different. The KTB had to record tactical decisions about when to snorkel and when not to, based on threat assessment and operational requirements. The supply log had to track any changes in consumption patterns related to snorkel operations. One technical change created ripples across all 5 logging categories simultaneously, and the fact that each category had its own dedicated log meant that none of these ripples were lost or blended together into confusion. Each discipline could absorb and document the new complexity in its own appropriate terms. There is also a command psychology dimension to the separate log system that deserves serious examination. A U-boat captain was one of the most independent military commanders in the history of warfare. Once his boat dove below the surface, he was entirely on his own. Real-time data from separate functional domains, maintained by accountable domain experts, available to the discipline layer. Together, they constituted a 2-tier documentation architecture that was remarkably sophisticated for its time and context. There is another angle to this story that has received very little attention, and it concerns what happened to the logs after the war. When Germany capitulated in May 1945, the Allies moved quickly to seize whatever German naval records they could find. Many records had been deliberately destroyed as German Naval Command recognized that defeat was inevitable. The order to scuttle the remaining U-boat fleet, Operation Regenbogen, was issued on May 4, 1945. Hundreds of boats were scuttled by their own crews. The logs aboard them went to the bottom. But significant quantities of records survived, either because crews chose not to destroy them or because shore-based records at naval headquarters in Flensburg and elsewhere were captured before destruction could be completed. The British and Americans immediately recognized the value of these documents. The separate logging system, which had been designed for German operational purposes, turned out to be extraordinarily useful for Allied historical and intelligence analysis for exactly the same reason it had been useful to German commanders. Each log type captured a different dimension of the patrol. Together, they allowed Allied analysts to reconstruct U-boat operations in extraordinary detail. By the late 1940s and into the 1950s, teams of naval historians were working through captured log sets, and the picture they assembled of the Battle of the Atlantic became the foundation of modern historical understanding of that campaign. The German naval archives, much of which were captured and then partially returned to West Germany over subsequent decades, now form one of the most complete operational records of any military campaign in World War II. The separate log system, maintained with German professional thoroughness even as the war turned catastrophic, produced a documentary record that is both a tragedy and a gift to history. A tragedy because of what it documents. A gift because of how completely it documents it. Consider what the captured logs revealed. The engineering logs from late war patrols showed clearly how the mechanical condition of the fleet was deteriorating as maintenance windows shortened and qualified personnel were lost. The supply logs showed the tightening of rations as supply line disruptions affected the Atlantic bases. The radio logs showed the increasing desperation in the communication patterns as headquarters tried to maintain control over a fleet that was dying faster than it could be rebuilt. The navigation logs showed boats operating in increasingly constrained areas as Allied air coverage expanded, and the ocean grew smaller and more dangerous. And the KTBs showed captains making increasingly desperate tactical choices, attacking more heavily escorted convoys, diving deeper, staying down longer, transmitting less, and still being found. Read together across all 5 log categories. A complete patrol record from 1944 tells a story that no single document could capture. It is the story of professionals doing their jobs with extraordinary precision in an impossible situation that they increasingly understood was going to kill them. The logs kept being maintained right up to the end, not because anyone forced them to at gunpoint, because the culture of professional accountability that the logging system represented was what these men were. It was how they understood themselves. And you do not stop being yourself even when you are losing. One of the most extraordinary aspects of U-boat logkeeping is what happened when a boat experienced a genuine emergency. Not the relatively routine tension of a depth charge attack, which experienced crews handled with practiced professionalism, but a true catastrophic emergency. A diving accident that took the boat below its crush depth, a flooding incident, a fire in the engine room, a catastrophic battery failure that released chlorine gas when salt water mixed with the sulfuric acid in the battery cells. In these situations, the log entries become some of the most remarkable documents in naval history. Engineers recording instrument readings in real time as flooding progressed. Navigators noting position as they attempted an emergency surface. Radio operators logging their distress transmissions with the same formal care they applied to routine traffic. The professional instinct to document overriding even the animal instinct of self-preservation. Some of these records end abruptly. The handwriting changes, the entries become shorter, and then nothing. These documents, found in wreck sites by divers decades later, or recovered from boats that somehow survived the incident, are among the most harrowing artifacts of the war. They are records of men doing their jobs until they could not anymore. The psychology of this is worth sitting with. When a boat was in mortal danger, the logging instinct did not disappear. It was too deeply trained, too much a part of what it meant to be a German naval officer. There are accounts of officers making log entries during depth charge attacks that lasted for hours, recording the number of explosions, the estimated depth, the damage observed, with the calm, formal language of professional documentation, while the hull creaked and the lights flickered and men prayed in the dark. The log was, in some sense, how these officers managed their fear. By staying professional, by doing the thing that professionals do, by recording. This connects to something important about military culture more broadly, and about the German military culture of this period specifically. The Wehrmacht and the Kriegsmarine placed enormous emphasis on Pflicht, which translates roughly as duty or professional obligation. It was not merely compliance with orders, it was an internalized sense that certain things must be done because they are what a soldier or officer or sailor is. The maintenance of the logs was Pflicht in exactly this sense. It did not require supervision. It did not require reminders. It was understood as intrinsic to the role. This cultural dimension also explains why the logs remained reliable documents even in conditions of extreme stress. A logging system that depends on external enforcement breaks down under pressure. When no one is watching, when survival is the only thing that seems to matter, when paperwork seems absurd against the backdrop of potential death, people stop doing it. But the German U-boat logs largely did not suffer this breakdown. They were maintained because the people maintaining them understood them as constitutive of their professional identity. Stopping would not just be negligent, it would be a kind of self-betrayal. There are some remarkable specific examples that illustrate all of these points in concrete detail. The patrol of U-96 in the winter of 1941, which formed the basis of the novel and film Das Boot, generated a set of patrol logs that historians have analyzed extensively. The navigation log for this patrol shows the boat operating in extremely heavy North Atlantic weather, with course corrections being made constantly as the boat struggled to maintain its operational area in conditions that would have challenged surface vessels. The engineering log from the same period shows the constant battle to maintain mechanical systems in a vessel that was being physically punished by the sea. The supply log shows the calculation of provisions against an extended patrol timeline. And the KTB, written by the captain at the time, Heinrich Lehmann Willenbrock, shows a commander making continuous tactical judgments under conditions of extreme physical and psychological stress. Read in isolation, any one of these documents is interesting. Read together, they create something approaching a complete account of what it was actually like to fight in that boat at that time. The separation of the logs was what made this synthesis possible after the fact. If everything had been in one combined record, The different types of information would have competed with each other, and a coherent picture would have been harder to assemble. There is another example that is even more historically significant. The patrol records of U-47, under the command of Günther Prien, who famously penetrated the supposedly impregnable anchorage of Scapa Flow in October 1939 and sank the Royal Oak. Prien's operation logs from that mission are among the most studied documents in naval history. The navigation log for the Scapa Flow mission is especially remarkable. It shows the precise plotting required to navigate through the channels into Scapa Flow at night, using currents, tides, and whatever visual references could be found in near-total darkness, while remaining undetected. The engineering log shows the boat operating on electric motors throughout the approach to minimize noise and avoid the detection that running diesels would have risked. The supply log shows the torpedo load and the sequence of firing. The radio log is notably sparse for the approach and attack phase, showing the communications blackout that operational security required. Together, these logs constitute the documentary record of one of the most audacious naval operations in history, and because they existed as separate documents maintained by separate officers with separate accountability, they have survived scrutiny and cross-checking in a way that a single officer's account never could. The navigation officer's position record corroborates the captain's account of where they were. The engineering officer's record of motor settings corroborates the captain's account of how they moved. The supply log's torpedo record corroborates the account of what was fired. No single element can be dismissed as self-serving or inaccurate without contradicting multiple other independently maintained records. This cross-validation function was not merely useful to post-war historians. It was part of the original design intent. The Kriegsmarine knew that in any after-action review, in any potential court-martial, in any dispute about the conduct of an operation, multiple independent records would be more credible and more useful than a single account. The separate log system was partly designed to make post-operation accountability possible in a clean and defensible way. By 1943 and 1944, the nature of what the logs were recording had changed profoundly. In 1940 and 1941, what became known as the Happy Time, the Glückliche, U-boats were sinking merchant ships at a rate that threatened to strangle Britain's supply lines. The KTBs from this period are full of attack reports, target assessments, torpedo expenditure records, and tonnage claims. The supply logs show full torpedo loads being expended and boats returning for resupply. The engineering logs show boats operating hard, but within their design parameters. By 1943, the picture was entirely different. Admiral Dönitz had been forced to withdraw his boats from the North Atlantic convoy routes in May of that year after catastrophic losses. The Battle of the Atlantic, from the German perspective, had been lost. The logs from this period tell a different story. KTBs that are full of records of attacks by aircraft and escorts rather than attacks on merchant ships. Engineering logs showing damage repairs made under impossible conditions. Supply logs showing boats returning with many torpedoes still aboard because they had been unable to find targets or had been too busy evading to attack. Radio logs showing increasingly urgent communications from headquarters and increasingly brief responses from boats that did not want to transmit longer than absolutely necessary. The logs were not just recording military operations. They were documenting the collapse of a strategic campaign and the process of systematic destruction of a fighting force, and because they were maintained with professional consistency throughout this collapse, they provide historical evidence of a clarity and completeness that is unusual for a losing side in any conflict. Losing sides typically suppress, destroy, or distort their records. The U-boat crews largely did not. They kept writing. They kept recording. They were professionals to the end. There is one more dimension to this story that is easy to overlook but critically important. The separate log system was also a crew protection mechanism in a specific and practical sense. When a U-boat returned from patrol, the captain submitted his KTB and the supporting specialist logs to Flotilla Command and ultimately to BDU. These records were reviewed. Claims for tonnage sunk were evaluated against available evidence, including the boat's own log descriptions of attacks and observed results. Credit for confirmed sinkings affected promotions, decorations, and the overall standing of a crew in the competitive and status-conscious U-boat community. But the log review also provided protection against unjust accusations. If an attack went wrong, if a torpedo hit a neutral ship, if there was a question about whether a vessel was a legitimate target, the detailed log record was the crew's first line of defense. The navigation log could show where they were and whether the area was an exclusion zone or not. The KTB could show what information the captain had available when he made his decision and what the target looked like to him. The radio log could show whether any warnings or restrictions from headquarters should have been known. This documentary record, maintained in real time under pressure, was far more credible than post hoc recollection and far more protective of individual crew members who might otherwise be vulnerable to blame for decisions that were genuinely made in good faith under difficult conditions. This protective function became particularly important in the later years of the war, as the strategic sit established the professional rather than criminal nature of what had occurred. The Nuremberg and subsequent